thanks. Yeah, good to be here. Thanks for hosting us. It's a pleasure sponsoring the pizzas and nice to meet a few new faces and all of that and get to know the community here. I'm a long-time fan of .NET. Also, a lot of JavaScript. I see Ashley's here as well, which is great. Yeah, hopefully you guys get something from both talks tonight. I think Chris has got some really cool stuff to share just now as well. So I guess before I jump in, maybe just a little bit of an introduction about who I am. I always love how companies have like useless stats on their website. So I thought I'd give a few useless stats about me. I've been with Intellect for the last 6 years. Before that, I was with a little web dev agency in Johannesburg, South Africa. And I got to build a lot of websites and make a lot of mistakes quite early in my career, which is really valuable. I didn't realize at the time, but it really was. And my role at Intellect is a technical lead. So at Intellect, we have a couple different pathways. Once you reach sort of more senior level, either you go more people side on the more team lead side, or you stay more technical on tools and you drive sort of quality and delivery, and that's sort of what I love to do. You might hear a funniness in my accent. So I am South African, if you were guessing or wondering. I moved here in February, so I immigrated over here with my wife and my daughter. So yeah, as you can see, I've killed a lot of Kubernetes pods. Like, I almost do it for fun sometimes. Now, just down the bottom there, Twitter. I'm not that active on Twitter, but if you guys do want the code afterwards, after the demo, you can just jump on my GitHub. It'll be there. Okay, just to talk a little bit about Intellect. We're now a global technology company, and we're run by technical people. So all of our founders who are still in the business are software engineers. Our roots are in South Africa. We started out in 2001, but now we're over 1,500 people strong, and we've grown into a number of different regions, which is really great. So we started in the Australasian region in New Zealand, and now we more recently in Australia, and we're growing really quickly. I think we're a unique consulting company because we actually live our values. I don't think that's all that common. I think you get a lot of bum and seat style companies, which are really not. So I've put our values up there. It's something that we really live: growth, relationships, and delivery, getting things done. If you are interested in having a little bit of a chat to me or Chris afterwards about maybe an opportunity or just learn a bit more about us, please reach out. Okay, so yeah, just before I even begin, you're going to see some terrible diagrams drawn in PowerPoint because I was going to write this whole thing using something cool in Markdown and maybe mermaid diagrams, and it would all be source controlled. And I started doing it, and then I was building a talk engine instead of working my talk. So I said, okay, no, let's just stop doing that. Let's just use PowerPoint. We'll draw there. I think I get the point across, so everything should be fine. If you don't understand anything that I say because of my weird accent, just put up your hand and I'll say it again. Hopefully in an Australian accent, I can give it a go. Yeah, there's some terrible puns and jokes in here, but hopefully you guys enjoy them. Okay, so just to sort of lay out the talk, we're going to start with some problems. We're going to look at a potential solution, some solutions. Then I'm going to try to give you guys all the theory you're going to need to know to sort of get out the blocks. And then we'll look at a demo, and hopefully it works. Everything's cool. Okay, so I want to start out with the good old days when everything was simple and everything was a monolith, and classes could just call other classes that had useful behavior or functionality in them. And hopefully, if you're doing things right, you had some sort of polymorphic abstraction that you were calling things via. And things were great back then. But with the advent of Kubernetes and distributed systems becoming actually quite easy to build, we started to deal with more and more integration. Not that integration is something unique, but more and more integration. Not just calling out to third-party services that we were using or are using, but calling to our own services, okay? And for some reason, when we call our own services, we tend to get a little bit lazy and we forget things. Like the fact that the network can be a nasty place to be. Making requests over the network can fail, right? And it can be a bit of a troll at times. And this request response model is everyone's default. It's like, okay, I need something, I'll just JSON over HTTP, right? Or maybe using some sort of hipster protocol like, GraphQL or, I don't know, gRPC. It doesn't really matter. That synchronous communication is tight coupling to that service, and you're making a marriage with that service. So usually what happens is that request sometimes fails, and you can't be asked really to figure out why, because the network is the network. So you implement some sort of retry magic using something like Poly, which is good. We should do this. Like Poly's great. If has anyone used Poly here? I'm sure you guys have. Yeah, it's great. Like you should be using things like Poly for reliability reasons and that. But we implement that retry magic and we move on, right? But then like some load usually happens. Hopefully we're all writing systems that actually get used. And that I use Salt Bay there, just sprinkling on a little bit of load. And that retry magic, which was put there for reliability, can actually start causing some issues for us. 3 requests might become 4 requests because of the unreliability of the network and so on. Things start to blow up. This is all synchronous communication. You then get a situation like this, which is all too common, and like the whole microservices problem where our microservices are slow, come and help us. I've seen this a million times. It usually looks something like this. You've got some sort of service, the Tony Stark service that you can see over there, and you're getting some load on that service. That service is making a request to our downstream service. There's some retry stuff going on to keep things hopefully somewhat reliable, but that service is relying on a whole bunch of other stuff, which it is also making synchronous calls to. One of the downstream services, a pigeon service, which actually sends a mail in this case, a physical mail, which might take a long time. So the lifetime of the request through the whole system, if you follow all of the hops, it's danger, right? Any point that fails in this whole request sort of topology is dangerous, okay? And we want to try avoid this. We also have horrendous performance bottlenecks going on. And as you can see here, like in this case, I can imagine that service dying, often under some load, okay? So the point is to be careful where you use synchronous communication. It shouldn't be the default. We need other tools, we need other ways of working, okay? And that's what I'm going to be talking about today. So let's look at some of those solutions. It's actually pretty simple. I think some people make it out to be a little bit more complicated than it actually is. Asynchronous communication is just some sort of communication facilitated by some sort of broker, okay? A message broker. In JavaScript context, there's a whole concept of the event loop, etc. And it's really just a service going via a broker to perform something. So in this case, service A wants to do some sort of collaboration with service B. It says, hey, broker, I want service B to know about this, and you've got this sort of middleman happening. And we'll look at the power of that just now. So service A goes ahead and sends a message over to service B via the broker. That took me a long time to get that animation working. So I didn't hear anyone clap there, but okay. Okay, thank you. Yeah. I was embarrassed that I'd never actually done one before, but now I have, which is awesome. And then I spent the next half an hour doing this next animation. So if you need a response, that's the next sort of question. It's like, okay, well, if it's just fire and forget, it's like everything's easy, right? But like, what if I need a response? So service A, of course, sends a message over to service B. Service B does some processing in its own time. It might be on holiday, I don't know, something's going on, and it goes ahead and it sends a message back to service A. That was 2 animations, if anyone was counting there. So the asynchrony is happening, and we've introduced eventual consistency into this application. That is the trade-off that we are making. So the state of the world is inconsistent from service A's perspective versus what's going on in service B. There might be some information that it needs to know about, but it doesn't know about it yet, okay? And that might be a problem, but oftentimes it's not. It's actually not a big deal because the world is inconsistent. It happens all the time. If you build things around it, that you can deal with it, okay? So this is where I sort of introduced this idea of an event-driven architecture. And I think this sounds like big, hairy, and scary, but it's really not. It's just really the idea of events being these notable actions that occur in your system. And when you care about those events, you do things based on them. You respond to them. And when everything is becoming events, or the majority of things are becoming events, you have this beautiful dance that just happens with all of your services together to facilitate a business process, okay? And by embracing that, you deal with all of those reliability, fault tolerance, etc. issues that we discussed early on. Okay, so the events sort of drive the behavior. Something that I hear a lot is I'm talking to someone about like driving something via events or an event-driven architecture. A lot of people say, oh, like event sourcing. Yeah, I've heard of that, you know. It's not event sourcing. It's like they sound similar. They're not the same thing. However, they can work together, okay? Event sourcing is a totally different thing that we won't go into, but they can work very nicely together, okay? And the thing is that you probably are doing this. Like most people have worked with queues and stuff. You're doing eventing. So, I mean, just on a high level, some of the benefits, there are a lot of benefits to embracing this approach, more than I could list on one size, but the main ones are there, right? We've got this idea of loose coupling between our services. We can have a service communicating with another service via a broker, and they don't even have to be written in the same language or use the same protocols. If they just communicate via that broker using AMQP or something like that, it's all good. They can communicate. You've got resilience, fault tolerance, scaling, etc., all built in and in a way that's slightly easier to control and that doesn't keep you up at night. Okay, you're not worrying about your one service being able to dynamically scale up as quick as possible, which again we'll look at. The downsides, there are a few. You do introduce another dependency into your application. You've got another thing to manage and worry about. But the advent of cloud computing and managed services, this does tend to go away, or at least get a little bit easier. And like I mentioned, you've got a little bit of eventual consistency that you're introducing, and maybe some complexity. Okay, but as you'll see, that there's not a lot of concepts that you actually need to know. Okay, and it's not like all or nothing. It's something that you can introduce a little bit where it makes sense. You don't have to make your whole system driven by events. That would probably be a poor way to spend money and time, especially if you've got an established system. But there might be some aspects of your system that could really benefit from this approach. Okay, so now we'll dive into just a little bit of theory, and just enough to be dangerous. So hopefully you guys don't break anything in production, but just enough, because I don't want to make it a 2-hour talk. The first thing is like this idea of a message broker. The message broker is really just a mediator, okay? It's its own service that deals with getting messages and delivering them somewhere. That's really it. There's a couple added concepts on top of that, and they are the analogies that they use are slightly different. So I've just listed a few there, like RabbitMQ, Amazon SQS, and you can also use SNS in combination with that. You've got Azure Service Bus, which you can of course use. All the good ones, you can usually communicate via AMQP with them, or there's some sort of easy to use SDK, or you could pick some sort of abstraction layer which makes it even easier. Okay, and I'll show you an example of that just now. Okay, it's usually really just an idea of, if you're in Azure, like you're probably just going to use Azure Service Bus. Just use it. It's going to work for you and it's going to be reliable. Okay. Cool. So the next sort of thing that you just need to understand is, we've been talking about events, but that's actually a poor name, an event-driven architecture, because there's actually two notable types of messages. It should be really a message-driven architecture, because a message can either be a command or it can be an event. A command is what it sounds like. I'm telling a service what to do. Okay, I'm saying create the manifest, update stock, ship the order. Like I'm telling it what to do. Okay, and the typical naming convention, as you can see there, is sort of verb noun. Okay, verb noun. With an event, it's something that's happened and I'm letting someone know. Okay, it's almost like a notification. So it's usually in past tense. Okay, and a command is usually sent directly to something. Hey, Chris, like give that talk, right? Whereas Chris says, hey, like everyone, I gave a talk. Publishes that message out. That would be an event. Okay. So an example of an event being obviously like, okay, well, the order was shipped. Okay, the manifest was created. It can trigger something else that might care about that event. Then just quickly, a queue and a topic. A queue is directed specifically to a consumer. Okay, so as you see there, we've got a sender. The sender knows that service B is listening to a certain queue. it pushes the message on following the contract that it knows that service adheres to or is expecting. And that consumer, when it's ready, can pick up that message and do what it needs to do. Once it's finished its work, it can acknowledge that message. We say ACK. If it's a bad message, it could knack the message, okay? Say that, hey, that's a bad one. But you'll see that using MassTransit, it actually sort of just takes away that whole, it abstracts over that completely. You don't even have to worry about it, okay? It also introduced this idea of a competing consumer pattern, which is almost the flip side of a load balancer, okay? So rather than a load balancer distributing load, the consumers work as quickly as they can, competing for messages as quickly as they can. Okay, so it levels out the load rather than dealing with the load balancer. I'll show you an example of that as well. A topic is pub/sub, publish, subscribe. Okay, so in RabbitMQ, this is typically done through an exchange. So you have an exchange which goes out to queues. So there's no real topic, but in Azure Service Bus, you've got an actual topic with subscriptions off of that topic. So it's a slightly different abstraction. The idea is the same. Okay, so it's sort of one-to-many is the key thing there. If you need one-to-many communication, you need a topic. Then just quickly, error queues. Depending on the broker you're dealing with, this might be known as dead lettering. Sometimes they are mixed together in the same broker. Okay, this can happen with Azure Service Bus, but not super important. Just understand the concept. So when you configure your consumers, you configure reliability of or fault-tolerant measures, how many times you should retry, what strategy you should use, etc. When you do that, it might just fail. That message just might be bad, right? We cannot deal with that message. We need a way to deal with that. We can't just delete the message because it might be important. We still might need to do something with it, but we also can't keep it in the queue because it's going to keep affecting our services. It's taking up compute. Maybe it's crashing a service. Okay, so we need a way of moving it off. That's what the error queue is about. Okay, so it's a way of sort of putting them in a pile where we'll deal with them a little bit later. Then just quickly some quick fire terminology that you might hear. So FIFO is just first in, first out. Okay, so it's the opposite of like a card deck. So if you put it in, that's the first one to go out. Okay, it's like a queue, a typical queue. Then you've got at least one delivery. Okay, so this is super important because at least one delivery ensures that that message will get delivered to one of your consumers that cares about it, but it might get it more than once, and we need to deal with that. Okay, and that introduces the idea of idempotency. Okay, so our consumers need to be able to handle messages in a way that results in the same state change. So if the ship order event occurs twice, for example, you don't want to send two things to the customer. Like, you're going to lose money pretty quickly doing that. Okay, I've actually got an example of this that happened to me recently where I had a payment plan with the ATO, and they were deducting funds automatically. Long story why I owe the ATO money. We'll save that one for the beer later. But the payment amount was deducted 3 times for the same month, and it's because their consumers, or whatever they were using behind the scenes, weren't idempotent. That's the government. That's frightening. But maybe I should show them this talk. Then you've got the idea of dead lettering. It's very similar to an error queue. Okay, it's the same concept. Just sometimes they can mean slightly different things depending on the broker. Okay. Then you've got the outbox pattern. So the more astute among you might think, okay, well, we've got a synchronous communication going on between the broker. Like, what about that? Like, we've just spoken about synchronous communication. The outbox pattern is a mechanism to protect against that. Okay, so instead of connecting directly to the broker and sending messages as if the broker is always around because network, okay, we go via a buffer. So we say, hey, I want to publish this message. We save it in some sort of persistent store, and then we try and send it, okay, when that broker is available. Okay. The next 2 important things are also important to understand. So we've got orchestration versus choreography, and this is how the messages work. Okay. With orchestration, you've got a single service which is managing the interactions between the services. Okay, so it's orchestrating what's going on, and it's centralized in a single service. it can fix that whole, or handle the whole distributed transaction problem when you've got a distributed application. So you've got many services, a whole bunch of stuff going on, but you want to make sure that they all sort of happen together, okay? You can use orchestration to do that. All the participating services just respond with events. So I send command to service A, it gives me a response back. Okay, cool, he's done his thing. Now I know that this service needs to go, like you go service, and he responds back. Okay, so it sort of orchestrates that process. Choreography is a decentralized way to do the same thing. Okay, so instead of having one service that's making sure that the whole workflow happens, we have multiple services participating in the workflow and they don't even know it's happening. It's like, I don't know, some sort of weird game where they just send messages and they hope something happens. They don't care. Okay, so these services just respond with events, and then another service goes, oh, I care about that, and then it does something, but the workflow is now a bit fuzzy, a bit more difficult to understand. There's nothing necessarily wrong with choreography per se, but sometimes what can happen is we don't realize we're building a workflow, a business process that should be cohesive, and we build it with choreography in mind by mistake, and then we end up with inconsistencies across the whole application topology, and we don't know what the state of the world is. We need to know what the state of the world is in the context of that transaction. So just to sort of illustrate this in a slightly more simple way, I've got some cool images that I introduced just to make this hopefully a little bit easier to understand. So choreography, we've got dancers, right? It's difficult to do well, especially if you're me. I've got 2 left feet. So when you're dancing with a group of people, it takes a lot of time and practice and attention to make sure that that all happens in a way that's seamless. It's not impossible. We can do it, but it's harder. Okay, so in this case, we've got the sales service, which says, hey, like there's been an order placed. So it produces a message that says, hey, an order's been placed. So the shipping service consumes that and says, oh, cool, if it's been placed, then I should ship something. So it ships and it publishes an event. And then the inventory service goes, oh, I care about orders that have been shipped, and it updates the product quantity. So this is not a terrible thing, but you can see that from the perspective of sales, they have no clue what's going on. If a customer calls in and says, hey, like, what the hell? Like, what's happening with my order? We don't know. Like, not without going and stitching together this transaction across the whole system. With orchestration, you've got a conductor, the sales service, the orchestrator, okay, and he's directing traffic and saying what's going on. So the sales service fires off commands, okay, which in turn is orchestrating events. So the sales service would say, well, place the order, shipping, okay, so the shipping service takes that order, goes, okay, sales, the order is placed. The sales service says, okay, cool, inventory service, update the product quantity. It fires off that command, and the inventory service fires back and says, cool, boss, the product quantity has been updated. And at that point in time, it may be in this business process, all good, that transaction's completed, we know it's successful, and it's done. This, in essence, is what a saga is all about. This is a saga. So you might have heard sagas, it sounds fancy. This is really just what a saga is. Okay, then just quickly, load balancing versus load leveling. This is what I alluded to earlier. Load balancing is the idea of a load balancer distributing requests across instances of a service based on some algorithm, like round robin or something like that, okay? And if the load starts to overwhelm those instances, hopefully we're monitoring some metrics and we can start to create new instances of that application. Hopefully quick enough, because we don't, we're going to start seeing these services run out of memory, run out of compute, okay, bad things happen, okay? It's not bad. It's not a bad mechanism. It's just different from load leveling, which is what when you're using queues or topics, that's what you're embracing. So you've got a producer, which is pushing to a queue, which is your buffer, and then the messages are just processed as quickly as possible. So it's something where we can be proactive about it. We can monitor the size of the queue, and is at the end of the world if a message takes a little bit longer to process, at least the services are still up and not getting absolutely walloped by requests all the time and running out of RAM and CPU and all the rest of it, okay? So we can lazily spin up those instances as fast as we need to. It's not the end of the world. It also opens up opportunities like, for example, you might have a business where you've got a premium tier and a basic tier. And if you're on the basic tier, your builds get processed only after all the premium guys, right? You could implement stuff like that quite easily using this sort of approach. Okay, this is the outbox pattern that I spoke about just now. So this is just the idea of the buffer, okay? So the queue would be hosted on the broker, but instead of going directly to the queue, we go via that outbox, okay? So it's a transactional outbox pattern, okay? It's a little bit of a lie, this diagram, but it gets the point across, because usually the sender service puts it in the outbox, and then it's also the one that's checking the outbox to send messages, but it's easier to explain this way. Okay, then just quickly, like a lot of people go down this path, and then they don't think about this. We might see that whole example of the request, and like, okay, cool, yeah, we need to go via broker, we need to do eventing, we need to do all the stuff, absolutely, and they embrace it, but they make their events as thin as possible. Thin meaning the bare minimum amount of information, maybe just the cart ID, the order ID, the user ID, user created or something. And they're sending it off to a service, and that service says, great, the user was created. I need to know all about this user. And it phones that service, and all the services are phoning that service, and we've undone all the work that we wanted to do, right? Because now we've got fan out coming back because we haven't sent enough information. So a FAT event would include all the information that might be necessary for the processing of that message without that service needing to phone home, okay? There's a couple downsides to it, so you need to be aware. The first is that you're creating a bigger contract with that service. So you have to adhere to that contract. If that contract changes, you're going to break consumers. So you just need to be wary of that. What is the other one? I've just blanked on it. But the main one is the contract issue. Oh, it'll come to me. I've just blanked on it. Okay. The next sort of thing is just, okay, this sounds complicated. Dealing directly with something like Rabbit or Azure Service Bus, or even Azure storage queues or something, it can be a little bit of work to set up. Like, makes sense to just use a library to make it a little bit easier for you, especially when you're starting out. I'm going to demo MassTransit, but there's a number of them which I've listed here. So Rebus, Wolverine is a cool new one that's coming out. I haven't really played with it yet, but it looks quite cool. That plugs into an event, like a normal eventing architecture. In Service Bus, CAP is a bit of a weird one. The documentation isn't great, but it's built around the idea of the outbox pattern, but it offers a lot of the similar features in a little bit simpler way. Or you can just use the SDKs directly, so whatever tool you're working with, okay? But they usually add some features on top. Something like MassTransit adds a lot of features that are just super easy. It's like batteries included. It's like, cool, like you want retries, like easy. You want this, it's easy, okay? And go through the documentation, you'll see there's a lot there. Okay, show me the code. There was a bit of theory. So I'm just going to demonstrate using MassTransit. It's the one I'm most comfortable with. And I'm just going to show you an example of a message consumer. It's actually really, really simple. The core interface is an I consumer of T, where T is the message or the event that you're consuming. Okay, so you inherit from that interface, you implement it, and I'll show you how you can automatically wire these up at runtime when the app starts. So you're not even managing any sort of crazy dependencies. It integrates automatically with the IOC container, so you can inject services and all of that. And you can see in this example, we are consuming submit order messages, okay? And this silly one, all it does is publish an order submitted event straight away without doing any work, okay? But you get the idea. Really simple. The thing that you should know is, when the message gets processed, if that function successfully completes, i.e. no exceptions, that message is automatically acknowledged, i.e. great, remove it off the queues, happy days, I never want to see it again, sort of thing, okay? If an exception is thrown, retry logic kicks in if you've got any, otherwise it will be dead lettered or errored. Sagas, Orchestration. The sagas look somewhat like this, a little bit different. There's actually two ways of doing sagas. The one is a state machine based approach, which is really cool but difficult to grok, especially if you're new to this. So I tend to lean a little bit more towards the consumer-based saga approach, just because I find it's a little bit easier to understand, especially from a junior's sort of perspective. The difference is that you have the state as a part of the saga, and you also have the consume functions as a part of it. So your saga is usually initiated by a certain type or a certain command. Okay, in this case, it would be submit order. That initiates the saga. At that point in time, a new saga is newed up, and it is saved to the database, and we can then track state. So you can see there's a couple of properties there of submit date and accept date. Those are arbitrary things that have been added to track the status of that saga. Like, what is the state? What has happened? What is the state of the world? Okay. As things go on, so let's say I receive the order accepted command. I get that command and I say, okay, cool. The next thing to happen is this, and it publishes another message. When that message comes back, goes, okay, cool, that happened. Update state, and the next thing to happen is the next one. Okay. The important thing to understand is that we're managing state. It's a state machine. It's not a place to inject services and call out to APIs and stuff like that. Its sole job is to orchestrate. That's it. Just to orchestrate, manage state. Okay, it's a mistake that people can make. Okay, the scary part. We're going to do a bit of a demo. I just wanted to sort of show it all in action. And I built a simple distributed application. And just to give you a little bit of a rundown, I don't know if you guys can see that on the top left, probably not, but I'm struggling to zoom in on that one. It's a different shortcut to this one. But anyway, basically we've got a few different services that are working together, backend services. We've got the cart service, we've got the order service, and we've got the shipping service. Okay. The first thing I'm going to show you is just a simple consumer. Okay, so if I open up this cart service, it's just a simple ASP.NET core application, and I'm just going to open up endpoints, and you'll see that I've created a controller. I've created a ping controller, and I'm just gonna ping this endpoint. So what this endpoint does is it takes a message and a should fail property from the URL, and then it publishes that to a queue, to a consumer that's listening. Okay. So the important things to understand here is we need an endpoint. So that's the queue, the named queue that we need. So we need to get that. We get that by the name, ping. This prefix of queue is a MassTransit thing, just so it knows. You can actually control some of the aspects of the transport, i.e. RabbitMQ, Azure Service Bus, via this URL stuff. So if you want to rather use things like exchanges, or you want to do fan outs, or you want to control durability of messages, all stuff out of the scope of the talk, but if you want to do things like that, you can customize it there. We get a reference to that endpoint. If it doesn't exist, MassTransit are going to sort that out for you. Don't worry about that. We're just going to get a reference to it. We're going to new up our command. This is just a record type. We're going to pass our message, and we're going to send it via that endpoint. Done. Okay. We don't know where it's going. We just know the address of it. We know the address of the message. If we come on down to messaging, this is just where I've put the consumer. You'll notice that there's a ping consumer. So like I showed earlier, all it does is it inherits from iConsumer of the command type that we just published. It injects some handy stuff like the logger, and it goes ahead and does some stuff. So what I've included here is just a way to force this message to fail. Okay, that's what the should fail is about, just because I want to show you how the error queue stuff works. So it just processes the message, but it really just does some logging. It has to basically return a task, and it needs to be async. Most things you're doing via consumers are async anyway, but it's not the end of the world if you need to just return a completed task. The one important thing to note is you can configure when you register a consumer, you can configure that consumer's retry policies and stuff like that right there and then. But I find that it makes a bit of a mess, right? Because you end up with these giant registration files of all the stuff, okay? So what I prefer to do is I prefer to register all of the consumers that implement the iConsumer interface within that assembly, and then you use consumer definitions to set up any stuff that you might want to do for that, okay? So one example is you might want to give it the exact named endpoint that we're going to send it to. So this ping endpoint lines up perfectly with ping that I showed you inside of the controller. And in this case, I'm actually going to set up a retry strategy. So you can see here that this is all baked into MassTransit. I'm setting up an incremental retry strategy, okay, with a retry limit of 3, and we're going to go every second, okay? Really simple. This is done automatically. What does it look like to connect to MassTransit? So I'm using MongoDB for storing the stuff. No big reason to do that. MongoDB is supported. So all of your major databases, Postgres, MS SQL Server, all of that sort of stuff. So I've just got a Mongo client set up. I just register MassTransit via the extension method on my services. Okay, this is a .NET 6 app. You can control all sorts of stuff, including the naming of your endpoints. This is up to you. It doesn't really matter how you do this. I just quite like kebab case. Then notice what we're doing here. So just ignore this for a second. But look what we're doing here. So we're adding all consumers from the namespace. Okay. This cart assembly reference is just it's a record with nothing in it, just so that I can easily get a reference to the assembly. So that'll automatically bootstrap everything for me. Then we've got to configure the transport. So in this case, I'm using RabbitMQ. I'm running locally. I'm running a RabbitMQ server just inside of a Docker container. Okay, so I'm just going to configure that service, and handily, it'll automatically use the default credentials to connect to Rabbit. Okay, so I don't even need to set up any credentials, but you would do that here. Hopefully, you've got different credentials in production. Okay, what's quite common is, and what a nice use case for RabbitMQ is there's no Azure Service Bus emulator, which is a pain in the ass. It's my least favorite thing about Azure Service Bus. So what you can do is, you're running in Azure, which is great, but you can use RabbitMQ locally because you just switch out the transport. You can have an environment variable which just switches it out automatically, which is really useful. Okay, so the next sort of thing that I like to configure is you can control extra settings via this MassTransit host option settings, and I just like to make that service wait for the connection and everything to get set up before it actually starts. Okay, so you can actually make it wait. Okay, wait for everything to get going, warmed up, and then it will go. Okay, if you do go look at the code, there's all sorts of nasty, not in production things, but hopefully we'll get the points across. Okay, so what we'll do is we'll go into our ping consumer and we'll place a breakpoint. This is already running. I'll jump over here. So it's just running on port 9001, and I've just got the Swagger docs open. So I'll just jump in here and I'll say hello world, and I'm just going to set should fail to false. Okay, we're going to go ahead and fire that off. See, so that went via the controller, hit the broker. The consumer's listening to that queue off of the broker, and that message has been delivered immediately to that consumer. Okay, because the service is doing nothing, right? We get that message and we can go ahead and debug it and step through it and do whatever we want to do. Okay, that's fairly simple. If I jump over to RabbitMQ, I can actually see the underlying queues that are going on. Okay, do I need to zoom in? Can you guys see that? All good. Okay, so you can see here that we've got a ping queue. There's no ready or unact messages. Nothing's going on because it was already processed. We've also got an error queue there. Okay, we've spoke about what that's about. Okay, so what I've done as a part of this demo, so if you do check out the code, I do just a custom Docker build for RabbitMQ, which includes a few plugins that make it a little bit easier when you're working locally. So there's a shovel plugin, which is particularly useful. When things fail, you can move them back to another queue. I'm going to demo that now. So let's jump over here. We're going to say hello world, and we're going to fail it. Okay, so bloody magic bar is horrible, especially in demos. Okay, so you can see that should fail is true. So we're going to throw a shoot and foot exception. And that's going to be a problem, right? So we're going to continue. and now it's going to try again. Okay, our retry policy is kicked in. You would have noticed a little lag because we had a 1 second delay. So it's going to keep trying. Try again. And we configured it for 3 times. Okay, so after the 3rd try, it's going to move it. Okay, cool. So that should have failed. So now if we go back to Rabbit, we should notice that, there we go, just takes a little bit of time. But you can see that the ping error queue has 1 in it. Okay, bad message, go away message, we'll deal with you later. Okay, we'll go fix our bug. And I'll just restart the service. Awkward silence. Go, Mac, go. Okay. So, okay, I've fixed the bug. Which one was it? It's over here. Okay, so now I've fixed the bug. I want to go and move things back. So one of the plugins that I spoke about, move messages. So I'm currently on the ping error queue. Let's move him back to ping. Okay, he's been delivered immediately back. Okay, and now if we place a breakpoint over here, he's going to succeed, right? He's going to make it past there. All's good with the world. So hopefully that lands, like the power of that, being able to do this and fix things later. Okay, you can basically just procrastinate with your bugs, which is quite actually a cool concept. I've just realized that. Okay, so the next thing I want to show you is going to be a saga. So if I actually open it over here, so sagas, if I jump back to the program.cs, they're similar but not the same. Okay, so they're registered via convention again. Okay, but we need a persistence mechanism because they're stateful. We need a way to store them. So we, in this case, configured the MongoDB repository. So this is just a way to store them, and it's fairly easy to do it. I'm just getting a reference to the Mongo client that I configured inside of the IOC container, as well as a database that I've configured. So it's just the cart database, and now we have a mechanism to store it. Okay, then so what I'll do is, okay, so I've just created a simple Docker Compose to pull all these services together. I stopped the cart service, it's running on my local, and then I've got the other services just running inside of Docker containers. I could start the cart service in here and stop it on my local, but I'm just going to avoid any demo gremlins for now. Okay, so you can see here that down on the left, I've got the order service logging out, and on the right, let's get the logs for that. DC is just a shortcut that I use for Docker Compose because it's long. Okay, cool. So now the other thing that you should note, or that I should show you, is hiding in the top here is just a little Vite server. So I did a little simple React application. I reckon it's going to be the next big thing. To be honest, I'll show it to you now. So basically, it's revolutionizing the online shopping game. It's a left-right cart. So you see products on the left and you add them to the right. Radical. So what I'm going to do is I'm going to add a couple glasses of whiskey, because Chris was asking one earlier. Okay, and then I'm going to go ahead and check out. But before I do, let's go inside of our saga. So our saga in this case is initiated by the checkout cart event. Now that's going to happen via a controller method. Not important, exactly the same as you saw for ping. Okay, just newing up a checkout cart and publish it via the bus. Okay, or via the endpoint rather. And you can see that it orchestrates these events. So a result of those commands are these events coming back. This version stuff is just some gnarly stuff that you need for Mongo, unfortunately, because it needs to know the version of the document. Okay, and then I've just hacked in this logger. So as I said, like you don't really want dependencies in here. So I wanted a way to show the things happening, like logging out. So I did this. Okay, an important concept is that you need a correlation ID. So this is usually the ID of the event that triggered it. Okay, so like in this case, it's my cart ID. I'm using the cart ID to correlate everything across the system because that's the managing service and how it identifies the process. And then we've got just some dates to track some state. Okay, and from there it's relatively simple. When the checkout cart happens, we set some state. Okay, so the cart checked out date is updated, and then we go ahead and publish another command for the next thing to happen. Okay, you can see that we've also got this idea of compensating actions. So order cancelled. So in this case, we said, hey, place the order. But maybe there was an issue. They can't place the order, right? So they say, hey, the order's cancelled. They send a message back. That's not the workflow we wanted, but it's the one we got. We have to deal with it. This gives us an opportunity to right the ship, fix whatever needs to be fixed, do something else to deal with that workflow. Okay, maybe we just need to delete the cart, or maybe we need to reinstate the cart so that they can try again. Okay, you can see how that compensating action can happen. Okay, then, but the actual like sort of happy workflow would be, okay, well, the order's been placed, and we'll get that message, and then we can do something else. So we can ship the items, for example. So you can see that I'm orchestrating from the cart service, I'm orchestrating the order service and the the warehouse or the shipping service. Okay, this is very simple, but when more services grow, this is a really easy way to understand what's going on. This is the centralized thing that I was talking about. You know what the state of the world is because you can go look at the database and see. Go look at the state. Okay, so I'm just going to quickly place a breakpoint over here. And we're going to test my React app. It is React, so it might fail. Okay, there we go. So you can see that it's hit our checkout cart breakpoint, and it's going to go ahead and process something. So I'm just going to let it go from here. And you can see that the order service has processed the message from the cart. The event service has processed that message from the cart, just to show that all of those actions were occurring. Okay. So that's pretty much me. I'll leave it there. I did have some bonus stuff, but I think just in the interest of time, I'll cut that short. But yeah, thanks so much for having me. So hopefully you guys learned something. Cool.
Just repeat the question for the stream if you don't mind.
Okay, no worries.
While you were going over the saga, then I was just wondering, how would you go about writing automated tests so that can you lock MassTransit?
Yep, there's a couple like utility methods that you can use for making everything in MassTransit quite easy to mock. But it's quite nice because it's just the state machine, and there's no dependencies, so you can just new up the saga and test it quite easily. Yeah, so it makes it quite nice. The state machine, the actual full state machine version is even easier because it's actually very functional. It uses a library called Autonomous or something like that, but it's like really elegant and quite cool. Sorry, say again? Yeah. So yeah, so what I don't mean pure. So sorry, the question is, as we said that the saga should be pure, but it wasn't because it was controlling some state. So in a pure sort of functional definition of pure, where data is decoupled from functionality and there's no side effects, what I mean by pure in that case is that there's no side effects being caused inside of the saga. Not necessarily that there's no state inside of the saga. By definition, it needs to have some state to manage. Yeah, because that saga is actually saved to the database. It's important that it's stored there. Yeah. Any other questions? Oh, go ahead. Yeah. Yeah, that's a good question. I actually should have showed it in my demo. So what you typically do is you create a separate project, which you could publish to NuGet or something like that if your application is stored across multiple repositories, and all of your other services registered to that NuGet package, okay? And that would have all of your contracts inside of it. But you can't rely on all of them updating in time. You're 100%, you bang on. So what you typically do is you just create a new contract, or you just use an additive model, similar to like in a database when you want to make a change, but you've got multiple instances of that application running at any point in time. It's usually easier to just add another column and keep the old column around till you know it's no longer used. So you can do stuff like that. Yeah, so I mean, it's usually in a distributed application, you've got some sort of phased rollout. So it's something that you would need to carefully consider if you're going to make a radical change to that message contract. There's no, unfortunately, like super simple answer for it, because it's like it depends. Like it depends on what you've changed. It depends on what is getting responded to, and you might need to do some work to get it right. So we actually had a situation where the contract changed dramatically and we couldn't just create another queue. So what we actually needed to do was we actually needed to pull some of those messages off the queue, change them and push them back on. But it's not the end of the world, but you might have to do something like that. Yep, go ahead. Yeah, I've looked at it. It looks great. I haven't actually had any time to try it out. It's been fairly rudimentary stuff usually, just NuGet packages really with the contracts, and that's been okay. I mean, it's a similar idea to dealing with REST APIs, but unfortunately, like you say, the documentation is not as good with contracts right now because people haven't embraced it in the same way that they've embraced just Swagger or the rest of it. But yeah, it's a great tool. I'd love to use it. Yeah, go ahead.
In the past, I've been used for doing contract level testing between services. And I just wondered if you've had any experience with like halfway between like integration and end-to-end testing in a distributed system model like we were describing.
Not really. Like not really, to be honest. Yeah. No, not that. I think we've focused on testing the state machines as much as possible, testing the edges as much as we can, right up until the edge. But like that in between, I think you can waste a lot of time there. Yeah. Yeah.
Sorry, just jump in. More of a comment. There is an in-memory backend for MassTransit, I think, that probably referring to earlier, that lets you do integration testing, in-proc integration testing across sagas and stuff like that. Right. But it often exhibits some out of order behavior because it's no longer asynchronous, it's now synchronous. So things can sometimes show up in different orders than what you expect. And you've got to kind of write your stuff around expecting things to show up in different orders and stuff. But I was doing end-to-end testing of sagas with MassTransit and RabbitMQ and Azure Service Bus on a project that did end-to-end or integration, not end-to-end, but integration testing using an in-proc in-memory, effectively service bus. But they say only use this for testing really loudly, and obviously you should listen to that. You should use it for production instead of RabbitMQ or Azure Service Bus. Yeah,
I played around with it. Like I found it quite flaky and difficult to deal with, and the value that it brought just wasn't worth the investment. And it's tricky to set up. It's yeah. Okay. Yeah, go ahead.
I'm not sure if you've already covered it, but do you have any thoughts on handling transactions, whether you're just working from a dead letter queue or you're compensating some transactional values?
What do you mean, like transactions in the idea of like a financial transaction or something like that, or do you just mean like a transaction in the state of the whole system? Yeah, so that's that orchestration pattern that I spoke about, and sagas are very useful for that. That's that distributed transaction. That's the fundamental way to deal with it, because then you have an opportunity to fix issues that might occur, okay, in the overall sort of how the systems talk to each other via events and commands. So if something happens that affects your overall transaction, you can respond to it. If you have a saga that just never completes, you can query the database, you could find out, and you can fix them, right? You can do stuff to those things. Okay, that happens. Sagas get stuck. Cool.